Okay, here we have summer chap 7.5. I guess that's grade 7, chapter 5, ratios and proportions. We have find the unit rate. Unit rate is like miles per gallon per 1 gallon, um, dollars per gram if you're buying food. Um, it's a unit, it's a single unit. So this is always going to be, here's our starting 84 miles per 12 days, but we don't want 12 days, we want per 1 day. That would be the unit rate. So it's per one. That's the unit rate. So we want to know what this is, how many miles. There's a number of things that you can do. Here's what we know, and we can go towards the unknown. So this is my known to unknown because it has the variable. And we always want to go from the known to the unknown. So I know this piece, 12 to 1. So we would divide by 12 in order to get that 1. So in order to create a proportion, we would divide this by 12. 84 divided by 12 gives us, what's that? That's 7? 7. Yeah, that's going to be 7. So x equals 7. So it is 7 miles per 1 day. If we do the other technique that you could have used was cross product. 84 over 12 equals x over 1, and we can do a cross product of these. Multiply those two will always equal the product of that, and you'll notice that you get the same exact thing. 12 times x equals 84 times 1. 12x equals 84. Let's divide by 12, and you get x equals 84 divided by 12, which is 7. So either way works. If it's proportional, we want to use the proportion. If it isn't proportional, then I would advise you to do the cross product of that. Find the unit rate. Okay, I like this because a lot of students struggle with mixed numbers. It's still the same thing. We're going to have a superfraction, 2 2/5 over 3 3/4 equals, this is kilometers per minute, equals what over 1 minute? And we can still do the proportional thing, or we can do the cross product. Let's do cross product just so you can continue to be familiar with this. It's probably the more realistic technique. So we have 3 3/4 times x equals 2 2/5. Whoa, that was not a 2 2/5. 2 2/5 times 1. Well, whenever we do this, we're going to change this. That's 4 times 3 is 12, plus 3 is 15/4. That's an equivalency. X equals, and we'll do this too, 5 times 2 is 10, plus 2 is 12/5. And when we have fractions multiplying my variable, and I want to do the inverse operation, this inverse operation, instead of dividing by a fraction, which would be crazy, we're going to multiply by the reciprocal. So we'll multiply both sides by 4/15, and we can simplify some of it. So that's 5, 3 goes into 15, 5 times 3 goes into 12, 4 times. And we get x equals, 16 25ths. Okay. All right, that's cool. 16 25ths kilometers per minute. I would not have a problem with that per 1 minute. If you want to change it to a decimal, you'd multiply that by 4. 16 times 4 is 24. So that's going to be 0.64 kilometers per 1 minute is another answer you might get. Okay, good. Tell whether the ratios form a proportion. So we write that 0, 1, 0. 1 over 0.4 should be equal to 9 over 3.6. And this is definitely where we use cross product, because the product of the numbers across should always be equal. And we have that equals 3.6, and that equals 3.6. So since these are equal, these proportions, these ratios are also. So that is a big yes. How did I multiply 9 times 0.4? 0, 36, 0, 0, 2 decimal places. That gives me 3.6. Tell whether the ratios form a proportion. 2 over 8/3 is equal to 2/3 over 6. We can still do that proportion. Or we can, that's a bad 2/3. Let's make that look a little bit more like a third. So we can do cross product. You have 8/3 times 2/3 should equal 2 times 6. That's going to be 16/9 equals 12, and that definitely does not. So these are not proportional. That's a nice, easy way. I'll show you another way. This is an interesting one. So this is definitely warrants some. So when we show this fraction, so I'm asking, hey, what times 2 would give you 2/3? That's actually an easier question than you think. We would multiply that by 1/3. Notice I go from 2 to 2/3, so I can't have anything in the numerator. I want 2 times 1, and then I need a 3 in the denominator, so I need to multiply it by a 3 in the denominator. So when I multiply, if I want them to be proportional, 8/3 times 1/3 does not give me 6. So there's another way of knowing that it is not proportional. Tell whether x and y are proportional. That means each fraction that we make, 2 over 10, should be equal 4 over 20. So that's times 2, that's times 2. So that one's a yes. And we're going to just look at each one of those. And that's 2 and 10, and that's 2 and 10. And that is 4 and 20. And so that's all these. So that's a yes, yes, and yes. The other thing that we could look is if we graphed it, it would need to be linear. So my answer is yes, it is proportional. Each one is proportional to any other point. It's not just the ones that are next to each other, 2 and 4, 4 and 6, 6 and 8, but it's also 2 and 6, 2 and 8, 4 and 6, 4 and 8. So all of them need to be proportional. We can look at that increase. That's plus 2, that's plus 2, that's plus 2. That means all of these increments must be the same also. If we're increasing the x's, my increase in y must be the same. That's plus 4, that's plus 4, that's plus 4. So the slope, the proportion is 2. So that is a yes also. Use the table to write a proportion. Okay, one proportion is 6 gallons to 100. To 8 gallons. All right, that's a little tricky. Usually you do, but our 6 gallons is to 8 gallons. Now see, 6 gallons refers to 180 miles. So, all right, so I'm sorry. So that wouldn't work. So that would not be one that we would make. We need M, since we're talking about M miles, we have to talk about 8 gallons. So this is a little tricky because it was very open-ended. I can put any number in there. So this is a correct proportion. 8 gallons, M miles, and 6 gallons is 180 miles. And here we have gallons to gallons, miles to miles. So this is one proportion representing this example. Okay, solve the proportion. So we go from the known, we know both, to the unknown. So 4 times what is 8 is times 2. So that's going to be 18. You also could have done 4 times x equals 8 times 9. 4x equals 72. Divide by 4. And you get x equals 18. This one we wouldn't use proportion. Or you could, but it'll be easier because there's no number times 4 that gives you 6, no whole number that is. So we're going to use cross product. Cross product will make it a little bit easier to solve it. So 4 times y equals 17 times 6. 4y equals, that's 42, that's 82. 17 times 6 is 82. Let's check. So notice that we do the math first, and then we check our work. So 17 times 6 equals 102. Did I not come up with 102? 17 times 6 is not 82. See, this is why we check. I was wrong, so now I know. Oh, that was really bad. 102 is the answer? Okay, 102. Hello, Mr. Mac. 102, yes, duh. Divide by 4, y equals 2. Okay, 25.5 maybe? Let's check it out. Did in my head, and now I'm checking my math. So 4 goes into 10 twice, which is 8. Bring down the 2 is 22, which is 5, which is 20. Decimal point, 0, bring it down, 5. So 25, so y equals 25.5 would be my answer. Tell whether x and y are proportional. If so, identify the constant of proportionality. Tell whether x and y are proportional. X and y are proportional, and my k value. Okay. Well, let's move the 11. I'm not totally familiar with this, but I think I know what we're going to do. I think I'm going to isolate my constant by moving it over. Xy equals 16. And then I'm going to solve for y? No, because x would be in the denominator. Oh, yeah. Yep, let's divide. This is a weird one. Let's divide by x. Divide by x, divide by x. Y over 1 equals 16 over x. That would be correct. And is it proportional? So is it 16, right? I mean, there's the equation, y equals 16 over x. So that looks kind of, we isolate for y, and we get 16. I'm going to assume that it's 16. Oh, no, or it's not proportional. Sorry, it's not proportional. I'm trying to make it work. See that? It's not proportional because x is in the denominator. We can't have x denominator. Proportion is y equals kx. That's a proportion. That's a direct variation, I think is what they call it. Variation. If x was in the denominator, it would be indirect. So I'm going to say they are not proportional. Let's go. Yes, I like that answer. We're going to check. So how do we see in this one? We'll multiply both sides by x, and you get y equals 8x. Well, 8x. Did I say my variation? Yeah, y equals kx. Good. So my k is 8. So they are proportional, and my k is 8 because we're going to use the formula y equals kx. That's my reasoning, is because we're going to put it in that format. We're going to solve for that template. Recipes call for 2/3 cup of flour. For every 1/2 cup of sugar, write the ratio of sugar to flour. Then find and interpret the value of a ratio. So the ratio of sugar to flour is 1/2 to 2/3. That is sugar to flour. So that's good. The value of the ratio. I've never heard of that term, the value of the ratio. Does that mean that it wants to be in a unit rate? I don't know this one. I don't know this terminology. So when we don't know something, let's look it up. What is the value of the ratio? The value of ratio is a single number found by dividing the first quantity antecedent by the second quantity consequent. For a ratio given A to B, the value of the fraction is A over B. Okay, so how to calculate? Here's an example. If it's 10 to ratio is boys, find the ratio. 2/3, which can be written as a decimal. So okay, I kind of think I know what I'm going to do. So, got it. Okay, so the value of the ratio is 1/2 over 2/3. And then we want to turn that into, we can turn this division to this type of division, so we can simplify it a little bit, because you can't have a fraction in a fraction. 2/3, then we get 1/2 times 3/2, so that is 3/4. So I'm going to say the value is 3/4, the value of the ratio. The amount of sugar in the recipe is blank the amount of flour. The amount of sugar in the recipe is how many times the amount of flour. So sugar is how much of the, so 1/2. How do you go from 1/2 to 2/3 times 1/2 times what? I like this. Times what gives you 2/3. So sugar in the recipe, I think it's this way. It'll be interesting to see, is, the amount of flour. The amount of sugar is, so, that's the equal sugar. Sugar is, so I actually did wrong thing. So it should be sugar is what percentage of the amount of flour. So, this flour 2/3. So 2/3 times what would give me that? So I want my 3 to become a 2 and my 2. So I think I'm going to multiply by 3/2, the reciprocal of this. 3/2, which gives me 3/4 equals that missing. So 3/4. Yeah, I like that. 3/4 again, value of the ratio. Now that's interesting. So do they correspond with each other? We'll find out. We will find out. The graph shows the number of cycles of a crosswalk signal during the day and during the night. So which one's night, which one's day? Day is faster than night. Night slows down. So now let's look at our questions. Write an equation that relate X and Y for both the day and night periods. An equation for the day period is, so we're writing an equation for these 2 points. So we would find the slope, which we go rise over run. So rise is, what's that, 25, 50. We're rising 80. And then we're running 2. We go right 2, so 80, so 40. So cycles, C equals, what do we say, 80 over 2 80 over 2, so 40H. So 40H, that would be an equation. The equation for the day period is C equals 40H, C representing the number of cycles, and H representing the number of hours. If we plug in 2, do we get 80? 2 times 40 is 80. If we plug in 4, do we get 160? Yep, so that worked. And equation for the night period, we're going to use these 2 points. We rise 60 and run 2. So 60 over 2 is 30. So we have C equals 30H. Good? Got it? Good. For how many more cycles occurring during the day than during the night for a 6-hour period? How many more cycles? Well, for a 6-hour period, so we would plug in 6 using this equation. C equals 40 times 6. So my cycle period would be 240 cycles. And then if we do H, we're going to plug in C equals 30 times 6 at night, which gives us 180 cycles. So we have 60 more cycles during the day. 60 more cycles during the day. I like that question. You needed to comprehend that. An engineer is using a computer-aided design, CAD software, to design a component for a space shuttle. The scale of the drawing is 1 centimeter equals 60 inches. The actual length of the component is 2.75 feet. What is the length of the component in the drawing? So that is 1 centimeter is equivalent to 60 inches. So this is scale and this is actual. So we are given this. This is the actual length. Now notice my actual is in inches. This is in feet, so 2.75 feet. We know that there are 12 inches in every foot. So if we multiply by 12, that's going to be 10. That's 14. I don't like that little curly Q there. Now it looks like a 12. That's 2 times 10, 14, 15, 4, 5, 2. That's going to give me 5, 7, 2, 1, which is 0, 0. That's 13. That's 5. That's 1. 2 decimal places. So that is going to be 153.6 inches is equivalent to how many in scaled value. So we would put an X there. So 60 times X equals 1 times 153.6. 60X equals 153.6 divided by 60. Divide by 60. When we divide by 10, we lose a decimal place. So this ends up being 15.36 divided by 6. And 6 goes into 15 2 times. With 3 left over, that goes in 5 times. With 3 left over, 6. So I'm going to say that it's actually 2.56 centimeters on the drafting board, on the drawing. 2.56 centimeters. We'll check that one too. A specific shade of green glaze. Oh, I didn't even see if there were any additional questions. I tend not to scroll down. A specific shade of green glaze is made 5 parts blue glaze, 3 parts yellow glaze. A glaze mixture contains 25 quarts of blue glaze and 9 quarts of yellow glaze. How can you fix the mixture to make the specific shade of green glaze? This is good. This is a big brain problem. So we have 5 is to 3 is to 8. So this is blue, green, total. That's kind of important. So the glaze mixture contains 25, 9, and whoa. Oh, yellow, blue. Why did I say G? Green. It's yellow. Yellow glaze. Hello, 3 parts yellow glaze. How can you fix the mixture to make sure the shade of green is good? Okay, so this is times 5. This isn't times 5. So if we assume, oh, right, and now this is a total of, that's a total of 34, right? 34. So 3 times 9. No, I'm pretty sure that, I'm assuming, we're going to assume that this is correct. So this is times 5. So this needs to be times 5. And so that would be 15. So we would need to add 6 more gallons of yellow, quarts of yellow. And if we do that, that gives us 30. Yeah, that would give us, that's a total of 15, which gives us a total of 40 total gallons. And if we multiply this by 5, do we get 40? Yes, we do. So that's good. So that actually worked. So we would need to add 6 quarts of yellow. That's good. I like that. I'm not sure if you understood how I did that, but that's a good way to check your proportions are correct. All right, here are the answers. So now let's go over. Let's go over these. Let's go to the pages. So I don't have the answer key with me. I'm at home, sorry. So 7-1, yep, that worked. 2 was 16/25 and 1. 16/25 and 1. 16/25 and 1. I like it. I like it. Number 3, didn't have the answer. Didn't have the answer. I'm pretty sure I'm correct on that one. What? Where are all the answers? There are no answers here. This isn't a very good answer key. Correct answer, 8/6. Yes, see, I knew that one. We're good with that. 18. Did we get 18 for number 8? Did we get 18 for 8? Yes, we did. We most certainly did get 18 for 8. Number 9, yep, 25.5. I remember that one. Number 10, doesn't say it, but ooh, I'd like to know that one. I'm confident with it. Oh, no, there it is right there. Yes, it's not proportional. That actually is the answer. Okay, I see. I never noticed that. That's actually the indicator. Yes, that's a yes and that's a no. Ooh, I thought I said yes and yes. Yeah, we'll go back to 6. We'll go back to 6 when we're done. Because I think I made a mistake on 6. These are good. 25.5 we knew. Yes, we said that it wasn't proportional. We said that K was equal to 8. That's good. 3 to 4, 3 to 4, 3 to 4. Did we get 3 to 4, 3 to 4, 3 to 4 on all those? 12. Ooh, we did not get 3 to 4, but we see why it would be written as 3 to 4 because we could write this as a ratio 3 to 4. So we get 3 to 4, 3 to 4. Okay. Slight little correction on that. Not correction, just a small little detail. That's good. 3 to 4. That's no more questions. Okay. 40x and 30x. Yup. And 60 more cycles. Pretty sure we said 60 more cycles. And 60 more cycles. Yep, that's good. Okay. That's that one. 60 more cycles. And the last two, 2.55. Did I say 2.56 or did I do 2.55? Let's check 14. 2.55? 14. Ooh, so I did make a mistake. 2.56. So let's check our math here. So 14. So we have, I kind of thought it was kind of weird that I came up with 153.6. I was waiting for it to be, so 12.75 times 12. I probably made a mistake here. 12.75 times 12 Should have given me 153. Yeah, so that was, oh, hello, that's 0, not a 6. Duh. Yeah, okay. So let's fix that. Let's clean that up a little bit. That's not a 6, Mr. Mac. That's a 0. Silly boy. Okay, so that's that. That's that. That's that. And then we would get 0.55. Sorry. Okay. We fixed that one. Let's fix that too. That should be a 5. 5 centimeters. Okay, let's go back. That's 14. And the last one, 15. What is 15? 15. Yeah, 6 quarts EL. We said that. Yep. And then I think I got number 6 wrong. Right? Didn't I say 6? Yeah. 6 is no. I think I said yes for 6. Yeah, I said yes. So that's +2. That's +2. That's +2. That's +4. +4 and +4. How is it not proportional? Right? That's 4. And 4. 7 + 4 is 11. That should have a proportion of 2. That's 4. That's 4. That's 2. That's 2. 3, 4, 5. 5, 6, 7. Well, let's write it as a proportion. I mean, let's do 1/3 equals 3/7. Okay. So, oh, hello. First one isn't Mr. Mac. Hello. 3 times 3 equals 9. Duh. That is really. 1 times 7 is 7. Mr. Mac. Not proportional. Duh. Sorry. Sorry about that. That's a big no. Not proportional. Sorry. And then if you, and we could actually do it this way. Let's check the problem before that. 40, 40, 120, 120, 240, 240. Let's go from this one to this one. You have 60 and 60. Let's go from this one to this one. That's 80 and 80. Yeah. So I like that little technique. See that? So if you stayed to the end, you found that Mr. Mac made a mistake. And then if we do these cross products, they never work. That's 11 and 15, 15 and 21. All right. I like that technique. That's a much easier way to show proportionality. Sorry about that. I did it for this one too. Isn't that funny? I did the proportion, then I tried to get different and tricky. All right. Enjoy.